Sorry about the miscommunication about lecture time. We had a misscheduling with a review session right beforehand. But from now on, our lectures will be normal time, 7:30 to 8:30, here in Geo 1 on Mondays. So to start off, welcome to lecture. There are a lot of you here, and we're very excited about that. Officially, like 153 people signed up for the course. So this is really exciting that all of you want to learn iOS development with us. To start off, so my name is Mindy, and this is my co-instructor Kevin, and we'll just introduce ourselves really quick. So, my name is Mindy. I'm a senior computer science major studying, or with minor in business. Last summer I was a software engineering intern at Apple working on photos. Before that I was doing iOS development at Bose. I'm an iOS developer on the Recast pod on AppDev. Also an iOS developer on the Cornell Daily Sun, and I used to work at Bell Apps. And if you can't tell which one I am, I'm the person on the left in the picture. Haha.
Hi, I'm Kevin. I'm going to be co-teaching this course. I'm a junior studying computer science. During my freshman year summer, I did iOS work at a startup called Blicky. On AppDev, I am an iOS developer on the PoloPod, which is our polling app. It's on the App Store right now, actually. And this past summer, I was a software engineering intern at Facebook, also doing iOS work.
We also have lovely TAs. A couple of them are here today, so wave. We've got Joe, Jaywan, Omar, and Maya here. We've got a whole lot of other staff, and they'll be holding office hours, grading your assignments, answering questions on Piazza, and stuff like that. Just to get a count, raise your hand if you are running Mac OS on a Windows computer. Okay, we've got a good number of you. If any of you have questions, Omar is your person to go to. He'll be coming to some office hours. He'll be here to answer any questions if you have any issues running Mac OS on Windows. All right, so some logistical stuff. So if you haven't signed up for Piazza, please do so as soon as possible. That's where we're going to have all of our course communication. So please do not email the team at Cornell AppDev email if you have an iOS question, or email our personal emails. It's just a lot easier to have everything in one place so that all of the instructors can see what's going on. Additionally, we'll be having weekly lecture handouts. I'm going to be trying to record all of our lectures so that you can, and upload them to YouTube so you can view them later for your reference. We also have a course website, and you can view our syllabus there. If you are adding for credit, please make sure you signed up for 2 credits. This is a 2-credit course. We don't want to shortchange you if you signed up for 1. And if you need to change that, just go to the edit section of Student Center. And the deadline to add is October 22nd. So if you haven't received a PIN, or if you would like to enroll for credit, please let us know as soon as possible. Make a private post on Piazza. Any questions? Okay, great. So the requirements, as we mentioned probably in the application of the course, you need CS 1110, which is Intro to Python or related experience. You need to have Mac OS, so either have a Mac or use the VM. We've linked the installation guide. There's also stuff on Piazza about that. And then you must have Xcode 9.0 with Swift 4. This is just to be consistent so we can run similar programs, because Swift is changing very quickly, and so is Xcode. Okay, so how do you make iOS apps? Let's start with kind of the 2 basic components that you'll need for iOS development. So the first one is Swift. We're going to be using Swift for all of our assignments, and it's a programming language developed by Apple to make iOS apps, Mac OS apps, watchOS apps, etc. It's really simple, it's expressive, it's fast, and it's safe. So we'll be going through some different data structures and data types later in this lecture. But some of you may have heard or even seen in our application form, there's 2 different programming languages that have been used by Apple to develop Mac OS and iOS apps, and there's Objective-C. So Objective-C is a lot older. It's been around for a really long time, and it has really ugly syntax. So if you ever encounter it, don't be afraid. They're very similar. So as you can see in this example, the top is Swift. So there's a variable called myString. You can store a string called hello world in it. And then you can call methods called like myString.uppercase, which will uppercase that string, so it'll be hello world in like big capital letters stored inside uppercase string. And in Objective-C, there's like the data types are declared before, so myString is declared as an NS string. You have these weird like ampersands because Objective-C is weird. There's also semicolons at the end of each line. So stuff like that kind of differentiates. You can see that Objective-C looks like a lot uglier, and Swift is much cleaner. Okay, so let's do a demo of Swift. So we're going to start off by using a playground. I set this up. So feel free to follow along, but also I'm going to be posting this lecture code after class is over. So if I'm going like super fast, it's because I want to cover as much as possible. And just refer to the reference code and the handouts later if you maybe like get a little lost. Okay, so we're going to start by opening Xcode. So I'm going to do Command space, type in Xcode. And it'll open. And so there's two different things that primarily you'll use in Xcode. The two things that I typically, like, we'll be making projects in later lectures, but we're going to start off by making a new playground. So click Get Started with a Playground. And just click blank. If you click Next, I'll call it My Playground, put it in, I'm going to change it to Lecture 1. Okay, so, all right, so we can see that a playground is basically an interactive development environment for Swift. And so here we can see two lines. The first one is import UI kit. That's importing like any library. So if you've seen like NumPy or in like Python, there's maybe like math for mathematical functions. This is essentially the same thing, but UIKit is what's used in iOS development to actually make views and have them show up on screen. So you can see here that there's a variable called string, and it's got hello playground inside of it. This is a variable, so variables can be changed. And if you want to run this, you can just click the play button, and it'll run. Oh, it's launching. So give that a second. So variables can store any kind of data, but once this data is in here, it's inferring the type. So now string automatically has the type string. So this is the same thing as saying, oh God. Oh, my computer's so slow right now. You can also declare the type of this variable by doing colon and then string, and you can also do hello playground. So this string can be changed. So if I want to change it, I can do my string equals hello world, and now my string will have the value hello world stored inside of it. And if I click the play button, it'll actually run this code, and you'll see it show up on this side panel over here. So now we can see the variable str has hello playground in it, my string has hello playground, and then when I set it to hello world, now it has the hello world stored inside. So these are variables, but we also have constants in Swift, and these are defined with let. So let's say I want to declare a constant with my netid in it. So let netid equals, my netid is mml234. You can fill yours in with whatever you want. And the difference between variables and constants is that variables can have their values be changed, but constants can't. So if we try and set netid to something else, and we try and run this, Swift is going to get mad at us, and it's going to say cannot assign to value, netid is a let constant. So this means that it's immutable, and once you store something in it, you can't change it. Okay, so let's say we also want to make something but declare the type beforehand. So kind of like how we did var myString equals string, we can say var label equals UI label. We'll learn what UI labels are next lecture, and we can just instantiate a UI label. So this is saying label has the type UI label, no other type can be assigned to this variable. So if I try and say label equals 2, it's going to get angry at me and say this is an incorrect type. So you can see down here in the console, or up here in the warning, cannot assign value of type int to type UI label. Okay, so now let's get into how to print stuff. So you can print to the console, which is this black box down here, or it's white. So you can wrap your prints with parentheses, and you can print anything you want. So if we print hello world, this will show up in the console down here. Another thing you can do is add strings or values of variables inside print statements. And how you do this is, if I want to say my net ID is, and then use this net ID constant I have up above, how you do that is my net ID is, and then you have to use the backslash and parentheses, and then put the variable inside. So this is kind of different from Python or Java, if you're experienced with those, where you can just add two strings together. This allows you to use not just strings inside here, but variables or integers and booleans, stuff like that. So if I have a constant called year, it's 2018, you can also print the year is, and then do backslash parentheses with the year. And so if I run this, it'll print hello world, my net ID is MML234, and the year is 2018. So now that we've done these print statements, let's start with some basic data structures. So arrays are pretty important. So how do we instantiate empty arrays? We can do two different ways. So you always have to declare the type inside the array. So if we want to do like lecture numbers, we can instantiate an array. Let's say we have like, these are numbers, right? So they're going to be integers. So you can do bracket int, and then you have to do the little parentheses to actually initialize it. So this is pretty similar to some other languages you've probably used. Another way you can do this is similar to how we defined var myString as type string. We can do var lecture numbers 2 is of type of int array. So this bracket syntax is saying it's of type integer, but it's an array of integers, and then we can just give it a blank array. So now it knows the type that's stored inside of lecture numbers 2. So, also, if you have any questions, please feel free to raise your hand, and the TAs will come and answer any questions you might have. Yeah. Okay, so now let's go through for loops. So let's say we want to add all the lecture numbers into our array. And this semester, we're going to have 10 lectures in this class. So this is going to be like a for I in like from 1 to 10. And I want to have 1, 2, 3, 4, whatever, all the way to 10 inside my lecture numbers array. So how to do this is for, let's say, number in. And so this is interesting and unique to Swift. You can do 1 ... to 10, and this will actually create like number will take on the values of 1, 2, 3, 4 to 10 in this range syntax. So now I can do lecture numbers dot append, and since it knows that lecture numbers is of a type of integer array, it'll automatically assume that the new element is an integer, and so now I can append the number into the array. And so if I run this, we'll see that this loop was executed 10 times according to the playground, and you can actually click this button and you can see the actual values that are inside. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are all in lecture numbers. Okay, so let's say we want to modify an array. So let's say we have a variable called course staff, and we can set course staff equal to, I'm not going to have everyone at the beginning, but let's say Kevin and Mindy. So what type is stored inside course staff? Can someone tell me? String array. Good. Okay, so now if I want to replace Kevin with, let's say, Joe, I know that Kevin is at the 0th index of the array, so I can say course staff 0 equals Joe. And now if I run this, we can see that Kevin and Mindy are now stored, and now we can inspect, and course staff 0 now contains the value Joe. Does anyone have any questions? Yeah.
How come we didn't have to write the type in course staff array?
Yeah, good question. So the question was, how come I didn't have to write the type when declaring the course staff variable? And the reason is because we already put values inside it, and Swift can infer from what values you put inside your array what type it is. So you don't have to include like string here, because it already knows there's two things, Kevin and Mindy, and these are both strings, and they're both in the array. It's only when you instantiate an empty array where you'll have to give it the explicit type of the array. Yes?
Do you put different, or objects different types inside the array?
You can. So if I did like Kevin and then 2, I think this will work. If I run this? No, just kidding, you can't. So this is basically saying you can't declare anything inside, and so you can't mix types. Yeah?
Do strings have to be denoted with double quotes?
Do strings have to be denoted with double quotes? Yes, in Swift they do. Yeah. Any other questions? Yeah. Yeah, good question. So if I didn't define the type and I still had Kevin and Mindy, and I wanted to change course staff to like 1.2, it's going to get angry because it's already inferred that the type of course staff is a string array, and so now it can't be changed to something else. Any other questions? All right, cool. Okay, so moving on. So now there's some special methods that you might want to use to, like, let's say remove items from an array at a certain index. So let's say now I want to remove Mindy from the course staff array. So that's at the index 1. So I can do course staff dot remove at 1. And now this will remove Mindy from the course staff array. So if I run that, it'll remove me. And then another thing that might be useful is like remove first or remove last. So if you want to just remove everyone from the array for right now, you can just do course staff dot remove last. And now if we print course staff, we'll see that the course staff array is empty here. Okay. So now let's talk about, now that we talked about arrays, there's also going to be another pretty useful data structure, which are dictionaries. So a dictionary basically maps keys to values, and these can be any kind of data type. So there's, again, two ways similar to kind of how arrays were initialized. So if you want to initialize an empty dictionary, let's say we have like a Pantry dictionary that stores like food with like how much food you have. We can do, so we want like the food to be the key, so that's going to be a string for us, and then how much of that food we have is going to be an int. So it's going to be string, comma, or colon, int, and then the parentheses. So this is saying the key is going to be a string, and the value is going to be a type int. And so similarly to how we declared arrays, we can say var pantry is of type string colon int, and then initialize the empty dictionary as bracket colon bracket. So these two things mean the same thing. Oh, and another thing that you might want to know is how to make comments in Swift, and the way to do comments is using the double slash, or using the slash star, like star slash. Okay. So how do we add stuff to the dictionary? So let's say we have 2 apples, so I want to add 2 apples to my dictionary. So I'm going to do pantry, and the key is going to be apples as a string, and this is going to map to 2. Similarly, we can modify this by just saying pantry of apples is equal to 4. So now pantry has, or now there are 4 apples in my pantry as opposed to 2. Yeah, question?
If pantry was a constant instead of a variable,
Mhm.
would you not be able to modify it like that?
Yeah, we can try it. So let's say we change this to a let, and we try running this. Yeah, it doesn't work because you can see in this error down here that we can't access anything in the pantry because it's been assigned to a let constant, which means we can't change it. So that means we can't modify or add like do anything to this pantry. So I'm going to change this back to a var. Okay, so let's say we have, we can also add like oranges, and let's say we have like 5 oranges. And then let's say we have like chocolate. And let's say we have like 6 chocolate. So how do we iterate through our pantry? So let's say I want to print out like I have blank blank. So like I have 4 apples, I have 5 oranges, I have 6 chocolate. So the way we do this is we can access this by doing another for loop. So if I do for, and then it's your key, comma value. So since the key is a food and the value is like the quantity, so I'm going to call these 2 variables for food, comma quantity, in pantry. Can add the brackets. And so here I can print. And so we're going to use the same like quote backslash stuff to insert these variables into my print statement. So I'm going to add the quotes, I have, and then do the backslash parentheses. And then so if the order is like I have 2 apples, I'm going to put quantity here. And then another backslash, and space, and then another backslash for the food. So what's going to happen when I run this? It's going to say, I have 6 chocolate, I have 4 apples, I have 5 oranges. So this is how you iterate through dictionaries. Does anyone have any questions? Yeah. Oh, he needs help. Yeah. Is it alphabetical? No. So when you iterate through dictionaries, it's kind of a random ordering. It's not necessarily alphabetical. Any other questions? Yeah.
Why do we name it quantity? Could it be anything?
Yeah. So the question was, why do we call it quantity? It could be anything. It could be like if you want. But this is a variable, so it's good to name the variable after what you're like accessing. So we could also call it like number, and this would work fine. So I would change this to I have number food. Any other questions? Okay, cool. All right, so now let's talk about functions. So you've probably seen functions before, and they're defined in Python. It's like def. In Java, it's like void or whatever value you're returning. So in Swift, all functions are defined by the keyword func. And let's just have a function that prints random, like something. So I'm going to call it print something. And you'll notice that I've capitalized the second word of this function name. And this is because in Swift, it's convention to use camel case, which means you lowercase the first letter and you capitalize every other letter of the word in your function. And we'll see more examples of this later. So let's say we just wanted to print like something. So this is literally printing something. So what this is doing is whenever you call it, you're going to call print something. And you should always use autocomplete. Autocomplete is your friend in Swift because some of the function names will get quite long. And so now if we run this, this is going to execute this function, and it's going to print the word something. So if I press run, you'll see something appears here. Does anyone have any questions about like basic functions? Okay. All right, so now let's have functions with arguments. So we're going to use the keyword func, and let's just call it add. And so what add is going to do, what add is going to do is take in two arguments, a and b, and these are both integers, and it's going to output an integer, which is the sum of these two arguments. So to do this, we're going to define the variable argument a, which is of type int, b, which is of type int, and to tell Swift that it's going to return something, we need to add this little arrow. So this is dash greater than. And we're returning an int. That's the output of the sum of these two numbers. So we're going to output an int and then add the brackets. And so to return the sum of these two numbers, okay. To return the sum of these two numbers, we're going to write return. And then so we have to do a plus b. So what this does is it takes in two integers and outputs the sum of them. So if we want to, let's say we want to store this, like the output of this add function into like a constant. So let's say let add 2 and 3, and we can store the result of add of 2 and 3. So now, what is add 2 and 3 going to have inside of the variable, or inside of the constant? If we put in 2 and 3. 5, right. Okay, so let's run this. And yep, add 2 and 3 has the value 5. So another thing we can do is use default values inside our functions. So let's say we want a function called like get paper area. And so let's say the paper usually is like 8.5 by 11, right? So, but sometimes the width and height are weird because you have like A4 paper or like construction paper or something like that. So let's say we have a func called get paper area, and it's going to have a width. And let's say since it's like 8.5 by 11, these are going to be floats, which are decimals. And it's going to have a height. And since we know the height is usually 11, we can specify this here, that the default argument is going to be 11. And it's going to output a float because we're calculating the area of the paper. So now, if we want to return the area, we just have to return the product of width and height. So we do return width times height. And so now there's two different ways now to call this function. We can say let normal paper equals, so normal paper is like 8.5 by 11, so we can say get paper area, and we only have to specify a width in this example, so we know it's 8.5. But let's say we have like weird paper, so we can say let weird paper equals get paper area. And so you can see here that there's two choices. One is for just having the width argument, and this one also has the optional height argument. So here if we want to specify some like weird paper, we can say the width is like 22 and the height is like 50. And so this is a way that you can sometimes specify what this argument is and sometimes not. Does anyone have any questions on optional arguments? Yeah.
Whenever you call a function, do you always have to say the name of the variables that you're putting as the parameters?
Good question. So when you're calling a function, do you always have to specify the name of the variables? In this case, yes. You'll see some examples of where you won't need the first argument. I can actually show that in a second, but in Swift, you will always have to have the variables, like the arguments defined. Yeah.
Do you have to use a let statement every time you call the function, or are we just being explicit?
No, yeah, you can, you don't always have to specify the let. You can also just say get paper area. Yeah. Other question? Yeah.
Why was in the second one the height optional, but in the first one it was not?
Yeah, so why was the argument for height optional in the first one, but then the second one it wasn't? This allows you to specify sometimes, like, it'll come in handy where you have a variable or, like, you have a function where sometimes you know the default value, but sometimes you want to specify it by yourself. So this, like, specifying float equals, or height equals 11 will allow you to bypass, like, manually passing in 11 for, like, the common case where, for example, like, paper is usually 11 in height.
Just ease of use.
Yeah. Any other questions? Okay. Cool. So another thing that you can do is have kind of anonymous arguments, but this is only for the first argument. So let's say we have func subtract, and you can specify an underscore here, which will prevent you from seeing the name of the first argument. So you can have a value called A, let's call it an int, and then B as an int. And this will output an int. So in this case, we can return A minus B. And so now, when you call this function, you can call, like, subtract, and you'll see that, like, A and int are both highlighted here, which means you're replacing both of them. So you can say, like, 6 and B is defined as 3. So that's, like, one example of making, like, the first argument anonymous, or not have the argument defined. Okay. Does anyone have any questions about functions? Yeah.
If our function didn't have any parameters but still return something, should we just take out parameters? And it would just be the same syntax as the subtract one, but nothing inside.
Yeah, so if you have a function that doesn't take in anything but returns something, so we can call it returns something. It doesn't take in any arguments, and it outputs, like, a Boolean. It'll return false. So this is the syntax for if you don't have any arguments, but you're returning a value, you have to have this arrow with the data type that you're returning. Yeah. Good question. What's the point of making a variable anonymous? It depends on a lot of things, but I think the way I think about it is sometimes the function call is explicitly, like, defining what your argument is. So, like, if you name a function like takes in a number, so you don't want to write, like, number again, because it's redundant. So in this case, it would be swiftier to just say this, and so when you call it, you know explicitly that it takes in a number. Versus if you don't have this underscore, if it says takes in a number 2, it just doesn't look as nice. That's, like, yeah, it's, like, not something you should really worry about, but it's, like, a little piece of, like, swiftiness that's cool in Swift. Any other questions? All right, cool. So now let's talk about some structs and classes. So you've probably seen classes and objects before, but if you haven't, it's basically like a data type where you can give your own field. So I work on a podcast app, so let's create a struct for an episode. And my episodes have two things. They have a name and they have a duration, which is, like, how many seconds the episode is. So we can define this as it has two variables. So the first variable is, we're going to call it name, and it's of type string. And then we have another variable for the duration, and this is how many seconds, so it could be like a float. Okay, and then we can also create classes, and I'll explain the difference between a struct and a class in a second. So let's say I want to make a podcast class. And this podcast is going to have its own name, and it's going to have its own episodes. And it's going to use these episodes that we just defined in this struct. So to do that, we're going to use the keyword class and do podcast, little brackets. And so it's going to have two fields, var name, and it's going to be of type string, just like the episode. But now it's going to have a list or an array of episodes. So we're going to say var episodes of type episode array. And we define it like this. And you can see now it's getting angry because it says the class podcast has no initializers or constructors. And so we can add this in. And so to do that, we're going to have an init. So it's kind of like the underscore init method in Python, or just like your public podcast in Java. So you can do init. It'll autocomplete this for you if you press enter. And it'll take in a name of type string, and it'll take in some episodes of type episode array. And so how do I declare or instantiate the name and the episodes of this class? We can do self.name equals name, and self.episodes equals episodes. So this is saying it's going to take in the name that you've given the podcast class and the episodes that you've been given, and it's going to put those and create a podcast object. So let's initialize some episodes to start off with. So let's say episode 1 equals episode. And then, so to instantiate, we need to open the parentheses, and it'll auto-complete this for you. So you just press enter. So let's call it constants, because we learned about that. Let's say we're making a podcast about this class. And the duration is like 10 seconds. So we can say this, and let's make another episode. So let ep2 equals episode. And then we can open the parentheses, press enter. The name can be functions. Let's make this one like 22 seconds, 0.2. Okay, so now we can create a podcast. So let's do let podcast equals, and so similar to instantiating an episode struct, we can do podcast and create a podcast object. And so this takes in, like we defined here, a name and episodes. So we can say the name is intro to iOS. And then we can pass in an array of episodes. So let's say we add our 2 episodes in. So now if I run this, you can see that this is of type podcast. And if you click on this button, it'll show you that there are 2 things inside. Oh, maybe not. Okay, it's not going to show you. That's weird. All right. Well, you can see that the name is going to be stored inside, and the episodes are going to be stored inside. Does anyone have any questions? Okay, great. So now you can access the properties of these podcasts and episodes. So let's say we want to print the name of the first episode. So we can do print, the first episode name is, and so to print this, we do the backslash parentheses, and we can do ep1 dot, so you can see there's 2 options here, and we want to print the name, and we can print that. So if I run this, it'll say the first episode's name is Constance. Okay, and so we can do the same thing for podcasts. So let's say we want to print the name of the podcast. So same thing, the first podcast's name is, with the backslash parentheses, we can do podcast dot name. And if I run this, it'll print the first podcast name is intro to iOS. Does anyone have any questions about printing variables? Yeah.
Did you print the episode with one name by saying podcast episodes?
Yeah, you could. So the question was, can you print the podcast name directly from here by doing podcast.episodes0.name. Yes, absolutely. You just have to ensure that the episodes array has at least one object in it, or at least one episode struct. And you'll see, yep, the first, well, it's incorrect, but it'll say the first podcast name is Constance. Any other questions? All right. Cool. So now let's talk about the difference between structs and classes. So structs are like value types. So this means that it's more similar to like a Boolean or a string as opposed to a class. So let's do an example of this. Let's create a new podcast. So let podcast2 equals podcast. Say the name is new podcast. And let's just give it no episodes. And the reason why you can just give it an empty array is that it already inferred that it's going to be an array of episodes. So you don't need to declare anything in here. And so now we can have a variable called podcast3 is equal to podcast2. And what this is doing is now podcast3 is pointing to podcast2 because podcast is an object. And so this means that podcast3 is technically the same thing as what was declared here. And so now if I change podcast3's name, newer podcast, what do you think is going to be the value of podcast2's name? Someone want to raise their hand? Yeah. So if I try and print this, podcast 3 or 2's name is now, and I run this, podcast 2's name is now newer podcast. And this is because podcast 2 and podcast 3 are pointing to the same podcast object. So if you modify podcast 3's name, you're indirectly modifying podcast 2's name. But if you have 2 episodes, so let's create a new episode. Ep3 equals episode. And it's going to take in a name, let's call it structs, duration 1. And now if we create a new episode that points to episode 3, and we change episode 4's duration to 5, what do you think is going to happen to episode 3's duration? Does anyone want to guess? Raise their hand. The same thing? All right, let's try it. So let's print episode 3's duration is now episode 3 dot duration. So it's still saying 1.0. And why is this happening? This is because an episode is a struct. So that means when you set episode 4 to episode 3, they're not the same thing. They're not pointing to the same object. All of the values inside of episode 3 were copied into episode 4, so it still retains the same information. That's why if you set episode 4's duration to 5, only episode 4's duration is now set to 5, and episode 3's duration remains the same. Does anyone have any questions? All right, cool. All right, one last topic. So in Swift, this is something that's pretty unique to Swift, is that there are these things called optionals. So we've learned that there are variables, so like regular int, and this is an integer of type 1. But there are these things called optionals, which means that it might be something, but it might be nil or null. So let's instantiate an optional int. And this is going to be of type, I'm explicitly declaring it as 1. And so this question mark means that it's optional. So I can also set an optional int to nil, and it'll be perfectly fine. So sometimes when you're checking variables, or when you're checking optional variables, this will come up a lot when you're creating iOS apps. You don't know what the value is inside this variable. And so you want to make sure that your app doesn't crash when it encounters a null value, or like something similar to a null pointer exception in Java. So let's say we want to check and print this is not null when an optional int is not null. So the easiest way to think of this is doing like an if statement. So if an optional int is not equal to nil, we can print it's not nil. And this will work fine. So for example, since optional int is nil right now, this isn't going to print. But a better way of checking this is using an iflet. So what iflets do is it specifically unwraps the value only when the value is actually there, so when it's not null. So we can say if let an unwrapped int equals an optional int. So now an unwrapped int is explicitly an integer data type. And now we know that an unwrapped int is definitely an int. It's not null. Like there's no way that it's null. We can now say print the value, value inside is, and then we can replace this with an unwrapped int. So this will always print an integer. So if I set an optional int to 5 here, we'll see that it'll print this value. But if I comment this line out or delete it, so let's make a function that does this for us. So we're going to use the keyword func, unwrap, and let's take in an optional int of type int. So how do we unwrap? We use if let unwrapped int equals optional int print the value inside is. Same thing as before. And so now, if we call this function, we can unwrap, let's say nil, and we can also do this on like 6. And so in both of these cases, one will print, you can see it here, and one will not. Another thing that you can do with ints is use a nil coalescing operator. And so what that means sounds very scary, but basically it's saying if the value inside is nil, replace it with this other value. So let's say that we do let unwrapped with default equals an optional int. So you'll see that this gets kind of, yeah, so this will be nil. But let's say by default we want it to have some sort of value. So like it's optional, so it might be nil, might be not. Otherwise, replace it with the value 0. And so now, since we know an optional int is nil right now, it'll replace the value inside with 0, as you can see here. Does anyone have any questions about optionals so far? Yeah.
What did the double question marks mean again?
Yeah, so the double question marks mean if this value is nil, replace it with the stuff on the other side of the double question marks, which is 0. So if I reset an optional int to be 5, you'll see that unwrapped with default is going to remain 5 because it's not optional. Yeah.
For the if let statement, do you have to use like an unwrapped and then like the type, or can you do any kind of like just a name, is unwrapped a keyword?
No. So the question was, does this always have to say unwrapped? No, it doesn't. So it could just say value, and then we could replace this with value. So you can name your variables however you like. This is just this side of the if let statement is the type that's not optional. So in this case, it's an integer. Yeah.
What's the name of the double question mark thing?
This is called nil coalescing operator. Yep. All right. So any other questions? All right, cool. So one thing that, one thing that you don't want to do is force unwrap your optionals. So sometimes you'll get like warnings in Xcode that'll be like, this value is optional, like what do you want to do with it? And sometimes it'll suggest like, let force unwrapped optional. And it'll ask you to put this exclamation point next to it. And what this is saying is, it doesn't matter what value's in it, I'm just gonna put it in force unwrapped optional. It could be nil, and it could crash my like code, but whatever, like we'll just see what happens. And so in this case, since an optional int is nil, if you press play, it'll give you, oh wait, optional int is still a value. So this is fine, like it's safe, but if I remove this and keep it at nil, it's gonna get very upset. And it's gonna crash. All right. Oh God. Okay. Guess it's just not working. Yeah. So you'll probably get like a red angry error inside if it's nil. So never use the exclamation point. You can always safely unwrap your optionals using your iflet statements. Okay. One last topic that I'm going to go try really quickly to go over is enums. So let's say we have like sizes, but we don't want to represent these sizes as like strings like small, medium, large, or like values 0, 1, 2, because that doesn't really mean anything to us. Oh, do you have a question? Okay. All right, never mind. So the way we can declare these sizes are with enum. So we can say enum, let's say we have like sizes. And we can have 3 different sizes, so the way you can declare this is case small, case medium, or case large. And another way to do this is, I'll just write it here, case small, comma, medium, comma, large. And so these aren't associated with any values like booleans or ints or strings. They're just like types. And so the way we want to do this, let's say we want to have let small size. We can say sizes dot small. And so that's the small size. Another way we can declare this is let medium size is of type sizes. And then we don't have to say sizes dot. We can just do dot medium because Swift can infer that it's of type sizes and it's the dot medium type of sizes. So let's say we want to print what kind of size we have. So let's have a function called printsize, and it'll take in a size of font or sizes. So one thing that we can do is taking our sizes, we can check what size we are and print like I am small or I am medium or I am large. So the way we can do this is using a switch statement. So this is saying depending on what size I am, I'm going to print something different. So if you type in switch and press enter, this will autocomplete for you. And it's saying we're going to switch on this value. And so we're going to switch on size. And so there's 3 different cases, as we can see up here, small, medium, and large. So we're going to do case small, print I'm small, case dot medium, print I'm medium, and then case dot large, print I'm large. And then we don't need this default statement because we've covered all of our cases. But let's say we have a case called like no size. And so then we're going to need a default, and we can print I'm a default. So this is saying we haven't covered all of our bases with small, medium, large. There's also no size. If I kept adding, I could have like another size. And both no size and another size inside my function would both go to this default statement because it's not a dot small, a dot medium, or a dot large. So now if I call this, let's say we can print size with dot small, and we run this. Uh-oh, I think it stopped running. Okay, it's having a hard time running, but it should print I am small, and if I do print size with like no size, it'll print I'm a default. Does anyone have any questions about enums? Really quick. All right, cool. Yeah.
It's just cases in like Java, for example.
Yeah, it's just like a case in Java. Any other questions? Okay, so I'm gonna switch really quick back. Didn't get to go through all the slides, but basically, brief overview, Xcode is what you just used to make your playground, but you can also make apps in it, which is what we're gonna be doing next lecture. And so for next class, please complete a post-lecture form. We'll be posting this on Piazza and on our website. If you haven't added yourself to Piazza, please do so as soon as possible. And we're gonna be releasing Project 1, which is going to be due Sunday at midnight. We'll have office hours. The office hours calendar is on the website. So if you have any questions, we're going to go outside because the next back-end class is starting soon. But thank you.